Okay, we are live. If there is anybody in the chat section, please let me know. Am I audible? Just give me a quick thumbs up in the chat section if everything is fine with my stream. Just give me a quick thumbs up in the chat. Let me know, guys, if everything is fine with my stream so that we can start our today's session. Okay, thanks, Gauri. Okay, third video. So this is a third video because last two videos we are having some technical issue. So the video is stucking so many times. So that's why we made those videos private, and we are having these sessions again. So this is a third session, guys, uh, for your machine learning course. Okay, so in today's session we are going to discuss about increasing and decreasing function and maxima and minima, because it is important to understand how to find out minimum value of a function. So I told you previously as well, and let me tell you once again that why minimizing a function, for machine learning, why it is important to know about how to minimize a function, right? Just give me a minute. Yeah, right. So let's see that why it is important to minimize a function. So we already know that for a machine learning model, what we have to do, we have some data set. We have a data set. We have one data set. Okay, so we have one data set. We can divide this data set into two parts, right? Training data, and test data. Training data has the actual value, so corresponding to x, I know the value of y, that is my training data. So I'll train my model based on the training data, right? So I'll get one model from here. Once I get a model from here, what would I do? I'll just give all the values of x and get the predicted values. That means corresponding to those x, I'll get the predicted value, that is y cap, right? Y cap is my predicted value. So the difference between actual value and the predicted value is what? It is my error, right? Difference between actual value and predicted value gives me my error, and I have to minimize this error because I want my model to perform well, right? And when would it perform well? When we have minimum error. So I'll minimize this error using maxima or minima, or using optimization of a function. So what is optimization? Optimization is basically finding out maximum and minimum value for a function, right? You can take some example. Let's suppose we have given three variables, x, y, z, right? I want to find out volume, right? Volume of a cuboid, right? X into y into z, I know that is the volume, but I want the maximum volume. So corresponding to that different values, I have to find out maximum volume. So that I can do using maxima or minima, right? That's how maxima and minima works. So that means if I'm saying that f of x is minimum, that means f of x is minimum at a particular value x, right? F of x is minimum at x is equals to a. If I'm saying that, that means my function is taking the minimum value at x is equals to a. Let's discuss this in detail. First, let's understand what is increasing and decreasing function, right? So good evening, Rajiv. Okay, so let's first understand that what is an increasing function and what is a decreasing function. So let's understand this. So let's suppose we have a graph. This is a graph. So when I'm saying that function is an increasing function, that means if x1 is less than x2, right? If x1 is less than x2, and I can say from here that f of x1 is less than f of x2. What does it mean? That as my x values are increasing, my function's value also increasing. Then I'll say that function is increasing. You can see that this is what? This is x-axis. and this is y-axis. We also say that this is fx value, right? So if I'll move to the right, right, that means moving to the right means on the x-axis that I'm increasing the values of x. If I'm increasing the values of x, that means if I'll move from here, that means up to this point my function's value is also increasing because we are moving in this direction as well, right? So you can see that. So that means if I'm moving to the right, from left to right, if I'm moving, my graph is moving upward, then I'll say that function is increasing. So that means from this point to this point, my graph is moving upward. So that's why my function is increasing, right? So my function is increasing here. But if I say that the value of x is increasing, x1 is less than x2, but function's value is not increasing, that means f of x1 is greater than f of x2. That means function's value is not increasing. What does it mean? That means if I'm moving from left to right, that means if I'm increasing the value of x, my function's value is not increasing, they decreasing. So I'll say that this is what, this is my decreasing function, right? So in the case when I'm moving from left to right, that means increasing the values of x, function's value also increasing, that means my graph is in upward direction, then I'll say that it is an increasing function. If I'll move from left to right and my function's value does not increase, that means they decrease, so I'll say that function is decreasing. So from this point to this point, function is moving in downward direction as I move from left to right, so that's why function is decreasing. And from up to this point, function start increasing again. Just let me know guys one thing, that is this function increasing or decreasing? Let me give you one example. So just let me know that this graph is increasing or decreasing. So the image I have shown here, from this point to this point I have this graph. So just let me know this function is increasing or decreasing. Let me know guys in the chat section, is this function increasing or decreasing? Let me know guys, is this function increasing or decreasing in the chat section? So I already told you that if we'll move from left to right and function's graph moves upward, then we'll say that function is increasing. Okay, right, right, Gauri, this function is an increasing function because you can see that as I'm moving from left to right, function's graph is moving in upward direction, right? So this is an increasing function. So you have to understand that what is an increasing function and what is a decreasing function. Okay, let me tell you one more thing, that we have different type of function. Let's take one example, that fx is equals to e to the power x. E to the power x is exponential function. The value of e here is 2.718, and this function is really very important when we are going to discuss logistic regression and all other further machine learning algorithms. So e to the power x is exponential function, and if I draw a graph for this e to the power x, when x is 0, e to the power 0 would become 1. So that means when x is 0, e to the power x is uh, e to the power 0 is 1. When x approaches to infinity, that means when, if I'll move values of x, my graphs increases, and then if I'll say this is a graph of this function. Let me draw it once again. Okay, let me draw it properly, right? So this is a graph of e to the power x function, right? Because as we increase the value of x, the function's value also increases. So that means e to the power x is an increasing function. E to the power x is an increasing function. We have another function which we say log x. Log x is again important. Logarithmic function. Logarithmic function graph is somewhat like this, right? It's somewhat like this, and it is also an increasing function, right? E to the power x and log x both are increasing function. Just remember this, the graph of these functions as well. And guys, one more thing I have to ask you, that do you guys know that what is inverse of a function? Let me know guys, what is an inverse of a function? What is inverse of a function? Do anybody know that what is an inverse? Okay, just one thing. So if I'll talk about inverse of a number, right? If I'll take 2, then inverse of a number is 1 by 2, right? If I'll take 10, inverse of a number is 1 by 10. That means we'll take a reciprocal. But it doesn't work the same way in functions, because if I have defined the function x, let's suppose if I have defined f of x is equals to x, this is a function, and it can be 0. If I'll put x is equals to 0, then there would be f of 0, that is 0. So I cannot take a inverse. That means I cannot take a reciprocal. So when I'll talk about a function, when I'm talking about inverse of a function, I cannot say take a reciprocal. So what does it mean to find out a inverse of a function? So let me tell you the definition for inverse of a function. That is f and g. F and g are inverse of each other. Inverse of each other. If f of g of x is equals to x and g of f of x is equals to x, that means I'll take a composition. What do I mean from composition here? That means first I'll apply g function, then I'll apply f. If I'll get x, then I'll say that function is f and g are inverse of each other. Let's take one example. So if I'll take here f of x is equals to x square and g of x is equals to square root of x, right? Now let's find out. So I have to first find out f of g of x. So first let's put what is g of x. G of x is square root of x, right? F of x is x square. That means in brackets we have x and I'm taking a square of it. So when I have f of square root of x, that means I'll take square root x square. Square root of x square gives me x. So that means f of g of x, I got x. Now similarly find out g of f of x. G of f of x, that means g of x square, because g of x is square root of x. When I have in brackets x, I'll take square root of the value which I have here in brackets. So here I have in brackets x square. So square root of x square, that would give me x. So here I can say that f of g of x is equals to x and g of f of x is equals to x. So that's why f and g are inverse of each other. So let me know guys if there is any confusion in the definition of inverse. Let me know guys in the chat section if anything is not clear about inverse of a function. So I told you this inverse of a function because exponential and logarithmic function are inverse of each other. They are inverse of each other. So you can see that if I'll apply f of g of x, that means f of g of x is, let's take this g, log x. That means e to the power log x is equals to x, and g of fx. G of fx is equals to g of e to the power x. That means log e to the power x. And logarithmic has the property that if there is something in powers, it comes to the forward. It comes forward. So it would become x log e, and log e is 1. So I'll get x. So just remember guys, e to the power x and log x are inverse of each other. Is that clear with everybody? Let me know guys in the chat section, then we'll move forward. That is this increasing, decreasing function and inverse of a function is clear? Okay. Okay, Gauri. Anyone else guys? Is there any confusion till now? Okay, so guys, can you tell me that the graph sin x function? So all of you know the graph of sin x. Sin x graph is somewhat like this. This is a graph of sin x. F of x is equals to sin x. So I want to know the function is increasing or decreasing. Can anybody tell me about what I can say about this function sin x? And tell me the function for x square as well. F of x is equals to x square. This is a graph for the function x square. So guys, you can see that in the graph of sin x, from up to this point function is increasing. So I'm using a arrow which is in upward direction to showing that it is an increasing function. From this to this point function is decreasing, because I can see that as I move from left to right, functions graph is moving downwards. From this to this point, function is again increasing, and up to this point, function is decreasing. Just let me know, is there any confusion in this, that how I am defining function is increasing and decreasing? And similarly here, if I'll talk about when x is, this is a f of x is equals to x square graph, right? So when I'm looking at the left hand side, left of 0, right, this is my 0 value. When I'm seeing here, if I'm moving from left to right, here function graph is moving downwards, so this is decreasing function from up to this 0 point, and from this 0 point function starts increasing, right? So guys, just let me know in these two examples, anybody have any question, let me know in the chat section. Guys, I am telling you from the start, from the scratch, the functions, increasing, decreasing functions, how the functions work. So for first increasing, then first decreasing, then increasing. Clear, ma'am? Okay, okay, Gauri. Anyone else? So guys, I have started machine learning from the very scratch. Like, I am just discussing mathematics topics as well before starting my main topic, that is linear regression. So just let me know if there is any confusion. Otherwise, we'll move forward. Okay, so let's see further. So we already discussed about x square. Okay, so guys, just remember one thing. When we have discussed about differentiability, right? I told you what is differentiation. Can anybody tell me what is differentiation? Can anybody tell me what is differentiation? Let's take a function x square, right? So just tell me guys that the function x square is differentiable or not. Just tell me this thing, that x square is differentiable or not. So guys, we have discussed that the function would not be differentiable if left hand derivative is not equals to right hand derivative. That is a formal definition. We do not have to use it. So our main definition, which we have discussed in layman language, that if I am able to draw a tangent at any point, that is differentiation, right? We have discussed that differentiation is nothing but a slope of tangent, right? So if I'll talk about differentiation, so if on any point of this graph I can draw a tangent, so that is differentiation. So this graph is differentiable, or this function is differentiable. So I can say that f of x is equals to x square is differentiable, right? That is clear. F of x is equals to x square is differentiable, because we know that the function is would not be differentiable if its graph has a breaking point or it has a sharp corners. Then it would not be differentiable. Otherwise, the function would be differentiable, because you can see that if I try to draw a tangent, I would be able to draw a tangent at any point. You can draw a tangent here, you can draw a tangent here, you can draw a tangent here, you can draw a tangent anywhere on the graph, right? So this function is differentiable. Now next thing to check here is that we have discussed that from we have started from here up to the 0 point. We have seen that the function is decreasing, and here the function is increasing, right? We have discussed that. So one thing we have here is that if derivative is greater than 0, then we'll say that function is increasing. If derivative is less than 0, then we'll say that function is decreasing. So now you can see that for every time it's not possible to find out a graph of a function. So how would I know that function is increasing or decreasing? So what would I do? I'll find out a derivative. We know all the formulas for derivative. If you do not know, you have to learn that, right? So just go through basic functions differentiation and just remember that, then you would be able to work on work on increasing and decreasing function and maximum minima, which we are going to further complete it. Right? So if derivative is greater than 0, function is increasing, derivative is less than 0, function is decreasing. Let's take one example. Let's consider this example. So if I talk about fx is equals to x square, if I'll find out a derivative, derivative of x square is 2x. Everybody knows, because we know that differentiation of x to the power n is n x to the power n minus 1. This is a differentiation formula. I hope everybody knows what is the differentiation formula here. So differentiation of x square is 2x. Now you can see that this 2x, when this 2x is greater than 0 and when it is less than 0, so I know that this f dash x is equals to 2x is greater than 0 when x is greater than 0, right? And f dash x is equals to 2x is less than 0 when x is less than 0. So I can see that when x is greater than 0, my function is increasing. When x is less than 0, my function is decreasing, because derivative is greater than 0 when my function is, when my x value is greater than 0. So now you can see that without looking at a graph, just checking out the derivative, I can easily find out where my function is decreasing and where my function is increasing. So let me know, guys, if there is any problem here with anybody. If you do not know how to find out, how to check increasing and decreasing without looking at the graph, just let me know. Let's just take a 1 minute and analyze what we have studied. And guys, let me know in the chat section if anybody have any confusion. Okay. Okay, so guys, tell me that, let's take one another example. If it is clear till now, so let's take one another example. I'm taking here a function e to the power x. We already discussed this, but let's check this is an increasing function or decreasing function using this. Right? If I find out a derivative f dash x, what would be the derivative? E to the power x. Right? We know that the derivative of exponential function is again an exponential function, right? And we know that exponential function is always greater than 0, because if you will take 2.718 to the power something, it would always be positive, right? So here derivative would always be positive. Derivative would always be positive, so I can say that f is an increasing function everywhere, because its derivative is always greater than 0, right, Rajiv? It always increases. Acha guys, just tell me about log x function. What about log x? Basically, I told you the graph of log x. Log x is only defined when x is greater than 0, because I told you that the graph of log x is this function. So it is defined when x is greater than 0. So tell me about the that is it increasing or decreasing? What about log x? Tell me guys about log x function, increasing function, right, Rajiv? It is also an increasing function, because if I'll take a derivative of log x is 1 by x, and because log x is defined when x is greater than 0, so f dash x is greater than 0, because x is greater than 0. So I can say that it is an increasing function. I hope everything is clear till now. Let's move forward. So guys, what we have studied till now, we have studied that what is increasing and decreasing function. Then we have discussed about inverse, and then we have seen that to find out increasing and decreasing function, we just have to use a derivative. Once we get the derivative, our work is done. I'll see that derivative value is greater than 0, then my function is increasing. If derivative value is less than 0, then my function is decreasing. I hope till now is clear. Everything is clear. Then move forward. Let's move forward. Okay, so guys, there is one more point here. So I told you that this, I have taken a graph for this function f of x is equals to x square. right? We have seen that here it is decreasing on the left side, on the right side it is increasing, right? So we have seen that derivative of f dash x is equals to 2x. We have talked about when x is less than 0, so that means we have discussed when x is less than 0, f is decreasing. When x is greater than 0, f is increasing. So what do I mean for x is equals to 0? There should be something at x is equals to 0. On real number line we have 0, all 0 also. So this point called as critical point, where my increasing and decreasing value changed. That means my function changes from increasing to decreasing or decreasing to increasing. Then I'll say that that is my critical point, and at that critical point either my maxima or minima would occur, right? Or I can say that many minima or maxima only occur at critical points. So that means, let's suppose I do not have to find out increasing or decreasing function, I just want to know that what is a critical point. So what would I do? I'll find out a derivative, that is f dash x. I'll take f dash x equals to 0, right? So whenever derivative is equals to 0, I'll say that that is my critical point. So that means f dash x is 2x, 2x is equals to 0. So from here I'll get x is equals to 0. So that means x is equals to 0 is my critical point, and I can check that to the left of x is equals to 0 function is decreasing, to the right of x is equals to 0 function is increasing, right? So can you tell me about this function fx is equals to e to the power x? What is a critical point for this function? Tell me guys, critical point for the function e to the power x. What would be the critical point for the function e to the power x? So what would I do to find out a critical function? I'll find out a derivative. So find out a derivative and equate it with equals to 0. So what would I do? I'll take f dash x. F dash x derivative is e to the power x, and I'll equate it with 0. So can you tell me what would be the root of this equation? What would be the value of x such that e to the power x is equals to 0? So there does not exist any x. There does not exist any x, right? We do not have any x such that e to the power x would be 0, right? So that's why there is no critical point. And I can see that the graph of e to the power x is always increasing, right? It does not have any maximum value or minimum value. It's increasing from the start. Just let me know guys if this is clear. Okay. Okay, guys, just let me know the critical point for this function. F of x is equals to x square minus 4. Tell me critical point for this function x square minus 4. Okay, not x square minus 4. Let's take it x square minus 4x. This is a function. Or let's take it x square minus 4x plus 2. Just let me know guys, critical point for this function. X square minus 4x plus 1. जल्दी से बताओ. I hope all of you know the derivative of polynomials. Derivative of x to the power n is nx to the power n minus 1. Okay, somebody is saying plus and minus 2. Just check it once. Are you getting plus and minus 2? Uh, okay. Gauri is saying 2. Okay, anybody else, guys? Rajiv is saying 3. Okay, so what would I do? I'll take a derivative, f dash x. What would be f dash x? X square differentiation 2x minus 4x differentiation minus 4, and 2 differentiation of 2 would be 0. So I have not written it. So what would I do? I'll equate it with 0. Right, that means 2x minus 4 equals to 0 gives me x is equals to 2. Right, so 2 is a critical point here. Right, so 2 is a critical point. Okay, let's just take one another function. F of x is equals to x cube minus 6x square and minus x cube minus 3x square plus x plus 1 plus 3x. Let me know what would be the critical point here. Right. What would I do? I'll take f dash x. That would give me 3x square minus 6x plus 3 equals to 0. Right? I can take 3 common. So what would I left with? X square minus 2x plus 1 equals to 0. So 3 can go to the right hand side. So I'll get x square minus 2x plus 1 equals to 0. And I can write down this as x minus 1 ka square equals to 0. So x is equals to 1 comma 1 as a root. Right, so I can say that, right, 1 is a critical point here. And guys, there may be a possibility that you can get more than one critical point, right? Because you can see the graph of sin x. This is a graph of sin x. So I told you that when increasing and decreasingness change, then we have a critical point. So we have a critical point here, we have a critical point here, we have this critical point here. So that means if I'll take fx is equals to sin x, what is the derivative of sin x? Derivative of sin x is cos x. I'll equate it with 0, and cos x is 0 at x is equals to pi by 2, and then we have 3 pi by 2, and then we have 5 pi by 2, then we have 7 pi by 2. So all these values, my cos x is 0. So all these values are my critical points, right? So I hope the critical point thing is clear to everybody. But till now, I have find out that at this particular critical point, there can be maxima or minima, but I have to find either it is maxima or minima, right? I do not know at this. I have find out all the critical points by putting derivative equals to 0. That I got it, how to find out the critical points. But now I have to classify that what critical points have maxima, at which critical point we are getting a maxima, and which critical point we are getting a minima, right? That I have to know. Because when we have discussed at the start that why we required maxima or minima, we have to minimize the error, right? So I have to find out a minimum value of a function. So let's see that. So this we already discussed, maximum, minima. So guys, just a minute. Yeah, so till now we have find out all the critical points by putting derivative equals to 0. So what I have done, I have equate f dash x equals to 0, and from here I'll get the critical points. Let's say x is equals to c1, c2 are all those critical points I got from here, right? So now at those critical points, at x is equals to c1, I'll check the double derivative sign. Double derivative, I hope you understand what does double derivative means. That means if I'm finding f dash x, right, I got f dash x a function 2x plus 6. I'll take f double dash. That means I'll differentiate this function again and I'll say that this is my double derivative. So I'll find out double derivative, that is 2. I'll check this function sign at x is equals to c1. If it is greater than 0, then I'll say that it is a local minima, and if it is less than 0, then I'll say that it is local maxima. Right? So that is a difference. Let me take one example and make it clear to you. Yeah, this was a function, right? So what would I do? I'll find out f dash x. F dash x. So that would be 6x square, 6x minus 36. That is equals to 0. Right? I'll find out first critical points. I'll take 6 common. X square plus x minus 6 equals to 0. From here, I'll get x square plus x minus 6 equals to 0. So that would become x square plus 3x minus 2x minus 6 equals to 0. So its roots would become x plus 3 and x minus 2. This is basic calculation, basic mathematics. So either this would be 0 or this would be 0. See, so we get two critical points here. X is equals to minus 3 and 2. Right? We got two critical points here. Minus 3 and 2. Just let me know, guys, if everybody is getting the same critical point, that is minus 3 and 2. So what would I do? I'll take a double derivative. Let's take a double derivative here, f double dash x. So double derivative would be, that means I have to differentiate this function. Right? So let's differentiate. 6x square differentiation is 12x plus 6. So this is our differentiation. Minus 3 and 2. Okay, right. So double derivative, I got 12x plus 6. So what would I do next? I'll take this point at x is equals to minus 3. At x is equals to minus 3, f double dash x. What it would become? 12 into minus 3 plus 6. That means minus 36 plus 6, that means minus 30. It is less than 0. So we have a local minima. Local minima. Right? At x is equals to 2. Let's take the double derivative sign. F double dash x, 12 into 2 plus 6. That means 30, which is greater than 0. Okay, sorry, this is local maxima. When it is, just remember this, when it is less than 0, it is maxima, and when it is greater than 0, it is minima. So we get local minima. At x is equals to 0, at x is equals to minus 3, I am getting local maxima. And Mayuresh, the third video which you were talking about, that has some glitch. So that's why I am teaching all this again. Right? We were facing the glitch there. The video is buffering. So all those issues. So that's why we made it private. I'll make sure that that video gets removed from the channel. So this is a third video, and you can find two videos which is public on the channel. I hope it is clear. So guys, tell me up to this point, it is clear. Let me, before that, let me tell you what does this local maxima I mean here. So it means that at x is equals to minus 3, my function f of x is taking maximum value. Taking maximum value. Maximum value. Right? And x is equals to 2. At x is equals to 2, f of x is taking minimum value. Right? So let me know if this is clear. If somebody asks me that what is the maximum value for this function, so what would be the maximum value? I'll put f of minus 3. So let's put 2 into minus 3 cube. I am putting minus 3 in the function. 3 into minus 3 square minus 36 into minus 3. So solve it, you will get the maximum value. And similarly, you can find out the minimum value. So let me know, guys, this is clear. Maximum and minimum value clear. Then I'll tell you that why I have written down here local. Just tell me that up to this point, if anybody have any question. Let me know, guys, if there is any question, because from next class onwards, so we are going to start linear regression. We are not coming back on the mathematics. Okay. So guys, okay, okay, guys. So here you can see on the board that I have mentioned word local, but you would ask that from the start I'm saying we'll find out maximum and minimum value. Now why you have used the word local, right? Because you do not know that what does this local word here mean. So guys, you can see if this is a graph. Oh, let me draw it again, guys. So I told you critical points are those points where increasing and decreasingness change. So if I'll start from here, my function is increasing, then decreasing. So that means this is my critical point. Now it is decreasing and increasing. This is my critical point. 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 This is my critical point, and this is my critical point. All these points are my critical points, right? All these points are my critical points, but you can see that. So if you will check the double derivative sign at this point, you would get less than 0, because you are getting a maxima here, and here you are getting a maxima, here you are getting a maxima, here you are getting a maxima. So in for a function there may be a possibility we get number of maximas. So that's why we'll say that these are my local maxima. So if I'll write down there that this x is equals to a, x is equals to b, and x is equals to c, and x is equals to d, or at x is, so that means I can say here that at x is equals to a comma b comma c comma d, f is taking local maxima, it's taking local maxima, right? There is one word, that is, one is local maxima and another one is global maxima. Global maxima means, that means out of this a b c d, I'll check that at which point my function is taking maximum value. So it is taking at x is equals to b maximum value, so I'll say that f is taking global maxima at x is equals to b. Just give me a time, let me clear this concept. I'll come to your question, right? I'll come to your question, whoever with this account named Indian dollar. I'll come to your question. Just let me know. First, I'll complete this concept, local maxima and global maxima, and then I'll come to your topic, come to your question. So, guys, what we have discussed here, that we can have maxima at A, B, C, D, because A, B, C, D both are, all these points are critical points, and you can see that they are taking maximum values here. So there are so many maximum values possible. Out of it, if I'll find out one maximum value which is taking the highest value, that is at x is equals to b, my function is taking highest value, so I'll call this as my global maxima. Global maxima, but all other maximas are my global maxima. So tell me, guys, if this is clear, that what is the difference between global maxima and local maxima, because when I'm going to discuss gradient descent, I'm not going to repeat this topic again. So just understand it carefully and let me know if you are facing any issue in this, because it is required in gradient descent if you have to understand it properly. So there are so many maximas possible for a function. There are so many minimas possible for a function. So if there are number of maximas, I'll say that they are local maximas. And if I'll take out of all those maximas, one highest maxima if I'll take, that is my global maxima. Similarly for minima, if I'll talk about minima, this is a minima, this is a minima, this is a minimum value, right? Out of it, I'll take minimum value. This is a global minima. Tell me, guys, if anybody have confusion in this. If there is not, just let me know in the chat section, because guys, this thing is important. So tell me if this is clear, then I'll move forward. There is one query. Mayuresh is asking, ma'am, for an interval, we get four maxima in that time trap. But we have to build a machine learning model where our maxima is the output. So in this case, what would be the answer? Yeah, Mayuresh, that's what I told you, that out of four maxima, we have to take maximum value. That out of these four maxima, what is the highest value? So you can see that this is one maximum value, this is one maximum value, this is one maximum value, and this is another. So you can see that highest of all is this one. So I'll take this one. So I have to train my machine. We are going to discuss this in gradient descent as well, that how would my machine take this global maxima instead of these ones. So we have to take one maximum value, that would be the, we'll take global maxima instead of local maximas. Okay, so let me know, other guys, if this thing is clear. Okay, so what is the takeaway from this whole whole board? What we have to take it away, that there may be a possibility that we can get number of local maximas. So if we'll get number of maximas, so we can say that they are my local maxima. If we get number of minimas, then I'll say that they are my local minima. We have to take out of those local minimas, I have to take the highest value, that is my global maxima. We have to take least minimum value possible out of all those minima, then I'll say that that is my global minima, right? I hope this is clear. Then let's move forward. So that's why, guys, I have given this local maxima and local minima. Okay, what we have written here. Okay, yeah. So guys, there is one another thing, that the if the, so we have discussed that if first derivative is 0, if second derivative is less than 0, then there is local maxima. If second derivative is greater than 0, then there is local minima. But what about second derivative we would get as equals to 0? There may be a possibility. Let's take function f of x is equals to x cube. Right? I'll find out f dash x. That is 3x square. I'll equate it with 0. I'll get the critical point x is equals to 0. This is my critical point. Now I have to find out that at this particular critical point, my function is taking maximum value or minimum value. I have to find out that. So what, for that I'll do f double dash. That is 6x. I'll find out at x is equals to 0, what would be the sign of f double dash x. F double dash x sign would be 6 into 0, that is 0. It is not less than 0 and it is not greater than 0. So I cannot put it into category local maxima and local minima. So neither we are having local maxima, neither we are getting local minima. So what would I say here? That this is my inflection point. Inflection point. Inflection point. That means neither I am getting maxima and neither nor I am getting minima. Derivative sign is changing. So we already discussed that we get the critical point where derivative sign change from positive to negative, or I have seen that where increasingness or decreasingness change. So if I talk about the graph of x cube, so this is the graph of x cube. So you can see that if I talk about derivative sign, because here my function is positive, here my function is negative, so that's why my derivative is taking negative value. But increasingness or decreasingness not changing, so that's why this is a critical point, but we are not having maxima or minima here, right? So there are three categories in which I can divide my critical point into: maxima, minima, and inflection point. So let me know, guys, if there is any confusion in inflection point. uh Mayuresh, where would I share the notes? Okay, from the next session, what would I do? I'll give you the Discord link and I'll share the notes there if that's possible. Let me connect with my team and I can see that where I can share the notes. I'll share the notes with you there. And guys, you do not get the written content which I have written here because it's not going to save, right? So either one thing you can do, I'm just not writing too much, so you can make your own notes with this, or you can take a screenshot while studying if that would help you. Okay, I'll look for it, right? So now we know what is inflection point, how the okay guys, tell me. Okay, so guys, one more thing, we call critical point as stationary point as well. Critical points are also called as stationary point, right? So when they are saying that find out the stationary point, that means find out the critical point, and they are asking that determine the nature of this point. That means either it is maxima, minima, or inflection. So tell me. Okay, Rajiv, let me see what I can do in this. Let me connect with my team and let you know in the next class. Till now, just find out maxima, minima, and this is a basic question. You can easily find. Gauri, I can share the notes, right? I can share the content which is already written, right? Which is written in black. That is not a problem. But what I am writing is not going to save. That's for that I have to connect with my team. If you want this written session, which is already written, then I can give it to you. That's not a problem. But what I am writing is not saving in this whiteboard because I am not using. Uh, I'm using this whiteboard. Basically. So let me see and let you know in the next class. Till now, tell me. So what would I do? I'll find out. Let's take it fx. I just want to write down fx because that seems correct to me. Or that, or let's say you can write down y dash as well. This is also derivative, right? Y dash. So there are too many notation: y dash, f dash x, or d square, dy by dx. So these are all the differentiations notation. When next starts, ma'am? Okay, next class would be on Friday at 5 p.m. Okay, so what would I do? I'll find out y dash. Y dash is 2x minus 2. I'll equate it with 0. I'll get x is equals to 1. And I'll find out y double dash. That is 2, which is greater than 0. Okay, y double dash is 2. So I'll write down that at x is equals to 1, double derivative sign is equals to 2. That is greater than 0. So we'll say that at x is equals to 1, f is taking maximum, or f is having maximum value, yeah, f is taking maximum value. Guys, as you can see here, I'm getting only one critical point, and at that point I'm getting maximum value. So I do not have to write down that it is a local maximum because I'm getting a single value. So there would be a maximum value at this point. Global maxima would be same here because I'm getting only one critical point here. So I hope this thing is clear. So this is basic question. Let's move forward. Okay, so guys, this is a question. They are saying that which of the following points is a local maxima of the function. So just try by yourself. So this function is given in this x comma fx type. Just try this thing by yourself and let me know in the comment section, or we'll discuss it in the next class. So guys, main thing we have here is optimization, the process of maximization or minimization. That means the process of finding out maximum value or minimum value. We say that this is my optimization. Right? I hope this thing is clear. That means for a function, we have to find out a minimum value when we are going to discuss about for machine learning. Right? This topic is in is calculus as well. Okay, there was one question somebody has asked that what does it mean, what does it mean function of single variable, right? Function of single variable. Single variable means that, let's suppose, how do I define a function? Let's start from the basics. What is a function, guys? Anybody know what is a function? Anybody knows what is a function? So if I have to define a function, that means what would I take? I'll take a from one set to another. That means I'll take a mapping from one set to another such that let's suppose I'm saying that y is equals to fx, such that f maps, that means f do not maps a single value to 2 points, right? There no not a possibility that f of 1 is equals to 4 and f of 1 is equals to 2. It cannot be possible. And this domain, this set a, has to be completely used up. That means all the values of a have the images, right? That is my function. When I'm saying function of single variable, that means I'm defining function corresponding to the only value of x, right? So that means I'm defining, when I'm saying two variables, so there may be f of x is equals to x square is a function of single variable. If I'm saying f of x comma y, that is x square plus y square, this is my function of two variables, because we have included two variables here, right? So there may be a possibility that I can take three variable x, y, z. So if I'll take x, y plus z, so this is my function of three variables. So you have only one variable case when we'll define f of x is equals to any function, right? That is function of single variable. And then optimization of single variable. So optimization of single variable, same thing we have done up to now, because you have only single variable in syllabus, and we in machine learning we are going to use that. It is required to use for uh, optimization with multiple variables, but we'll see that how we are going to do that in multiple regression. So guys, let me know up to this point if anybody have any confusion. Okay guys, so that's all I have for today's session. From the next session onwards, we are going to start linear regression. That means on Friday we are going to work on linear regression. Just let me know if there is any question, any doubt in today's session. Just let me know, because we are going to start linear regression from the scratch, and we are going to move up to regularization. That means ridge and lasso, and we'll see that how they are going to benefit us in regression. And then we are going to discuss multiple regression, bias, variance, all the things we are going to cover in linear regression. So let me know guys if there is any confusion, any question in this. Just let me know. I hope this thing is clear, guys. If maxima and minima is clear, then you can easily understand gradient descent, because I already told you increasing, decreasing. So, guys, before understanding gradient descent, just give a quick revision what we have studied in next class. Okay, so guys, that's all from my side. I'll take 1 minute for any questions. If there is any question in the doubt in the comment section, then I'll end the session. Okay, thank you guys. Thank you so much.